Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our second lesson on vectors, whereby we are looking at our example number 2, which is also a question worth 10 marks. So the question reads that in the figure below, OPQ is a triangle in which OS is equals to a third OP. So we need to interpret the given ratio. So we are told that OS is equal to a third of OP. So the first thing we are going to do is to separate the numbers with the given vectors. So for me to achieve that, I'm going to divide through by OP. I also divide the other side by OP so that I can remove OP from this side. So this one simply means that OS to the ratio of OP is actually equivalent to 1 to the ratio of 3. So this ratio can also be interpreted as OS to the ratio of OP is actually equal to 1 to 3. Therefore, the direction of our ratio is actually this direction, that is from O towards P. So this is the direction of our given ratio from O towards P. Then clearly the ratio of OS will actually be given by 1. So from O to S, this ratio is 1. Then from O to P, remember OP is the total ratio or the total line, which is actually 3. So if O to P is actually 3, if the whole of this is 3, it simply means that S to P, its ratio will be 2. So that when you take 1 plus 2, you will get the total ratio, which is actually 3. Now, after interpreting that, we can also move to the second statement that we are given. So we are also further told that the ratio of OR is actually equal to a third OQ. So if OR is equals to a third of OQ, this one simply means that I'm going to divide both sides by OQ. I also divide this other side with OQ so that these two can cancel out. So I remain with the ratio of OR to OQ being equivalent to 1 to the ratio of 3, which can be interpreted as OR to the ratio of OQ is equals to 1 to 3. So clearly the direction of our ratio will be from O towards Q. Therefore from O to Q, this is the direction of our given ratio. So the ratio of OR is actually 1. So from O to R, its ratio is 1. Then from O to Q, the ratio is actually 3. Now remember, O to Q is the whole of this line. So if this one is 3, it simply means that RQ will actually be 2. So that when you take 1 plus 2, you'll get the total ratio of 3. So that is how to interpret those two ratios. Then you are also given another ratio. We are told that T is a point on QS such that QT is equals to 3/4 of QS. So if QT is equivalent to 3/4 of QS, it simply means that for me to get the ratio, I'm going to divide both sides by QS. I also divide by QS so that the QS can cancel out. So QT, the ratio of QT to QS, this particular ratio will be 3 divided by 4, which can also be interpreted as QT to the ratio of QS. This one will be equal to 3 to 4. So the direction of our ratio is from point Q towards point S. So this is our Q, then that is S. So the direction is from Q towards S. That is the direction of our ratio. Then the ratio of QT is actually 3. So Q to T, this ratio is 3. Then Q to S, its ratio is 4. Now remember, Q to S is the total line. So for me to get a total ratio of 4, if this is 3, it means that this one must be 1. So that when you take 3 plus 1, you'll get a total ratio of line QS being equal to 4. So that is how we interpret the ratios if they are given in this particular manner. Then I'm going to move to part A of the question. So part A, the one that we are told that given that OP is P, so the vector of O to P is P, So again, the direction is similar to that direction. So this is the vector actually P. O to P is P. The directions are the same. Then we are also given that OQ is Q. So O to Q directions are also the same. So this is vector Q. Express the following vectors in terms of the vectors P and Q. P and vectors Q. So Roman 1, they want us to express that is the vector SR. So we need to express the vector SR in terms of P and Q. So we go to our figure, we pick a root that gives us a complete triangle that has known values. So if I look at SR, the possible roots that gives us a complete triangle will be SO or R, or the other possible root is SQ, then QR. But the root that is seeming to have most of the values is SO, then OR. But remember, if you also use the root of SQ to QR, the answers will actually be the same. So I'm going to pick the easier root to work with, which is from O, that is OS, then from O, that is back to R, because the direction is from point S up to the point R. So this should give us, this one should give us the following. So we are going to get the following. So SR, I'm going to use SO, the direction of vector SO, then I'm going to add OR. So this will be equal to, so remember when we move from S to O, we are actually negating the initial direction of the ratio, which was upward. So whenever you negate, you reverse the direction, you introduce a negative. So this will be the negative of, so we'll pick the ratio of OS, which was 1. So this is 1, then divided by the total ratio of that line was 2 plus 1, which is actually 3 of vector OP. So of vector OP. So remember, SO is negating the direction of OP. That is why I'm introducing a negative here. But if they were moving in the same direction, then it will just be a positive. Therefore, SO will be 1 divided by the total ratio, which is 3 of vector OP, but negative because this direction is reversing the original direction, which was moving upward. Then I'm going to add OR. So OR is moving in this direction, which is the same direction with this, hence it will be a positive. So OR, its ratio is 1, so this will be 1 divided by the total ratio is 1 plus 2, which is actually 3 of the vector OQ. So they are moving in the same direction with the vector OQ, hence the positive. So this will be equivalent to negative a third. Vector OP was actually vector P. So this is a third vector P, then plus a third. OQ was actually vector Q. So this is vector Q. But it is always good to start with the positive. So I can indicate this as a third vector Q. I'm starting with the positive, then minus a third vector P. So because a third is common, you can also factor out a third so that you give it as Q, then minus P. So either this one or this, any is acceptable. Then we move to Roman 2. So Roman 2, they want us to find the value of the vector QS. So we need to find vector QS. Again, we are going to pick the root on the diagram that gives us a complete triangle that has most of the known values. So the starting point is Q, the ending point is S. So this is our point Q, so we need to move up to point S. So we have two possible triangles. We have QP, then PS, but we don't have the value of PQ or QP. Therefore, that root will not be valid. So I'm going to use the root that I have most values that gives me a complete triangle, which will be QO, then OS. So I'm going to use the root of QO, then I'm going to add OS, QO plus OS. So QO plus OS has most of the values. Therefore, that will be the valid root. So QO is actually the negative of OQ. So because when we move from QO, we are moving in this direction from Q to O, which is reversing the original direction, hence the negative. So this will be the negative of vector OQ. So this will be the negative of vector OQ. Then we are going to add OS. So remember, O to S, we are moving in this direction, which is the same direction with the initial direction, hence a positive. So OS will be, the ratio of OS is 1 divided by, so 1 divided by the total ratio of line OP is actually 3, or simply 1 plus 2, then of vector OP, of vector OP. Of course, OS and OP are moving the same direction. That is why I'm having a positive. Then I'm going to separate these two with a line this way, so that if I proceed with my working, I need to substitute the values here. So that means that QS, the vector of QS, will be equal to negative OQ, but vector OQ is actually Q, so this will be negative Q, then plus a third of vector OP. Vector OP is simply vector P. So if I start with the positive, I'm going to have a third. So this will be a third vector P, a third P, then minus vector Q. Then I'm going to move to Roman, that is Roman 3 of the question, whereby they want me to find the vector of PT. So Roman 3, they want us to find vector PT. So similarly, I'm going to find a root on the diagram that gives me most of the known values and gives me a complete triangle. So PT, the starting point is P, the ending point is actually T. So for me to find this PT, I can use the root of PQ, then QT, but of course I don't have the value of PQ. Therefore, the other alternative root will be PS, then ST. Yeah, actually that root has most of the known values. Therefore, PT will be PS. So this will be PS, PS, then I'm going to add. So this will be PS, then plus ST, plus ST, which will be equal to PS. When we move from P to S, we are moving in this direction. The starting point is P, the ending point is S. So you can see this direction is reversing our original direction, which was moving upward. Hence, whenever there is a reverse of direction, you introduce a negative. So this will be negative of PS. Its ratio is actually 2. So this is 2 over the total ratio was actually 1 plus 2, which is 3 of the vector OP. So vector OP, of course, is P. So let me just write vector OP. Then I'm going to add ST. So ST, its ratio is 1. So if we move from S to T, let me use a different ink here. So you can see the direction of S to T is reversing the direction, the original direction of the ratio. So whenever there is a reverse of direction, immediately you introduce a negative to account for that change of direction. So this will be negative. The ratio of ST is actually 1. So this will be 1 divided by the total ratio of this line is 3 plus 1, which is actually 4 of the original vector was from Q, that is the original line, that is the total line was Q to S. That is the total line in relation to the original direction of our ratios. So the whole line was Q towards S. That is why we indicated this direction upward. So of QS. So negative a quarter of QS, which will be equal to the negative of 2 over 3 vector OP. I believe we have it, which is actually vector P. So this is 2/3, negative 2/3 vector P, then minus a quarter of QS. I believe we have vector QS. We have it here. That is in Roman 2. So QS is a third of vector P, a third vector P, this one here, then minus vector Q. So if I open the bracket, I'm going to have negative 2 over 3 vector p, then of course minus, this will give us negative 1 over 12. Negative 1 over 12, because 4 by 3 you'll get 12 of vector p. Then negative times negative will give you a positive. So a quarter, negative a quarter multiplied by negative q, you'll get positive a quarter. Then of course we add the q. We add the q. Then here we have some like terms. So let me separate these lines here. Let me separate the working space. So we are going to have the following. You can see here we have some like terms. Negative 2 over 3p, then minus 1 over 12p. So if I start with the positive value, I'm going to have, let me start with a quarter q. So this will be positive a quarter vector q, positive a quarter q. Then if I take negative 2 over 3, then I subtract negative 2 over 3, then minus 1, minus 1 over 12. So negative 2 over 3, if you subtract 1 over 12, you are going to get negative 3 over 4. So this will be minus 3 over 4 vector p, minus 3 over 4 vector p. So that is my pt. Then of course in Roman 4 I'm asked to also find the value of vector tr. So our vector tr, so tr will be equivalent to, so we also check on our diagram the root that can give us a tr, that of course is a complete triangle and has most of the known values. So the easier root to work with, we have tr can be ts plus sr, but we don't have sr. No, we actually have sr from part A of the question. So we can use this root. So tr will be given by, remember we can as well use the root of tq plus qr. The answers should be the same. So tr will be given by ts. So this is ts, then we add, tr will be ts plus sr, of course, which will be equal to, so ts, the direction is upward, which is similar direction to the original direction of the ratio of 3:1 which was used. Therefore ts will simply be equivalent to its ratio is 1 divided by the total line has a total ratio of 3 plus 1, which is actually 4. So this will be 1 over 4. Then they are moving in the same direction with the original vector, which was qs. So this will be positive 1 over 4 of vector qs, Then we'll add sr. We already have sr from Roman 1 here, which was 3 over 4. So this was giving us sr was actually the simplified one. We had it here. So our sr was here, which was a third of q, then minus a third of p, So this was a third q, then minus a third p, correct? So this will be a quarter into qs. I believe we have qs somewhere. Our vector qs is here. So this will be a quarter into qs, was giving us a third vector p. So this is a third vector p, then minus vector q, a third vector p, then minus q. Then I'm going to add a third of q, then minus a third of p. Then if I open this bracket, I'm going to have 1 over 4 by 3, I'll get 12, 1 over 12 vector p, then minus a quarter times q, I'll get negative a quarter q, then plus a third p, that is a third q, then minus a third p. On simplification, I'm going to have the following. I can actually choose to start with, I can add. So we have p here, then you also have a vector p on the further end here. The other one is, I can start with q because this will give me a positive value. So if I pick negative a quarter, so negative a quarter plus a third, negative a quarter plus a third, I'm going to get positive 1 over 12. So this will give me 1 over 12 vector q. Then I'm also going to add these other two which have p, so I'll add this one and this one here, which of course is 1 over 12, 1 over 12. Then of course we are subtracting 1 over 3 minus 1 over 3. I'm going to get my answer as negative a quarter. So this is giving me negative a quarter vector p, negative a quarter vector p. So that is the vector tr. Then part B of the question, we are told hence to show that the points p, hence to show that the points pt and r are collinear. So in order for us to show that those particular points will be collinear, we need to have the vectors of pt and also the vectors of tr, which I believe we already have them. Yeah, because we have that is pt. I believe we got some pt somewhere. I already have my pt here. I also need tr. I also have my tr somewhere here. Okay, so let me clear out this area so that we can work with whatever we have to prove that they are collinear. Remember, showing that any three set of points are collinear is simply to show that those particular points lie on a straight line, such that the points, the vectors formed from those points will have a scalar multiple, showing that the two vectors are parallel. Then we need to show that there is a point which will be shared. So you just write the points in the order given. So we have p, then the other one is t, then the other one is r. So the vectors that we need, the first vector will be the vector in between here. So we need vector pt here. Then the other vector, you pick it from these points, tr. We also need tr. So that the point that will be shared will actually be point t. Then if we need to show that these vectors are collinear, we need to show that one is a scalar multiple of the other. So for us to show that, I'm going to say, I'm going to let pt to be equal to a certain constant of vector tr, so that if we find that there is a scalar multiple between the two, we shall have proved that the two vectors are parallel. So my pt was here. This was my vector pt. It actually simplified to this particular vector here. Therefore, I'll just pick it. So I'll say 1 over 4 vector q, then minus 3 over 4 vector p should be equal to k into vector tr. So vector tr, it's simplified into this. So this is 1 over 12 vector q, 1 over 12 vector q minus a quarter vector p, So on opening the brackets, I'm going to have a quarter vector q, then minus 3 over 4 vector p being equal to 1 over 12k vector q, then minus a quarter k vector p, of course where k is a constant. So from here I'm simply going to equate the coefficients of similar vectors. So I'm going to equate q with its corresponding value of q. So if I equate the coefficients, it simply means that a quarter q should be equal to 1 over 12k q. So of course my vectors q will cancel out also, so I'm remaining with a quarter. So a quarter is equal to 1 over 12k. So if I want to get the value of k, I'll multiply both sides by 12. So by 12, I also multiply this side by 12. So that 12 and 12 will cancel out. So k clearly will be 12 over 4. Of course, 12 divided by 4. If you take 12 multiplied by a quarter, you will find that your value of k will actually be equal to 3. So k will be 12 over 4. You are going to get 3. Remember, you can also prove it using the other coordinates. So I can also prove it using this other point, so that I'll have the following. So suppose another person was working with point P. You can also prove using point P, whereby you'll simply say that negative 3 over 4p should be equal to negative, so I'm equating p with p, so is equals to negative a quarter kp. So of course the p and p will simply cancel out, so the p and p will cancel out, so that I'm going to remain with negative 3 over 4 will be equal to negative a quarter k, negative a quarter k. So if I want to get the value of k, I'll multiply both sides by the reciprocal of negative a quarter, which will be, the reciprocal is just 4 over negative 1. I also multiply this side with 4 divided by negative 1. So of course negative 1 and negative 1 will cancel out, 4 and 4 will cancel out, so k will be equal to, negative and negative will cancel out, 4 and 4 will cancel out. So you remain with negative 3 over negative 1, which is also giving you the value of k as being 3. So it doesn't matter the vector that you choose, the values of k will actually be the same. Now once you get the value of k, you simply rewrite the equation that you had. So remember our equation, we had said that we are letting pt to be equivalent to ktr. But because we have already found the value of k, therefore it means that the vector of pt will be equal to our k, we found it as 3, so this will be 3 tr. So this one we have proved that pt and tr are actually scalar multiples of the other. So when you show this way, it simply means that, hence this one is showing that pt, the vector pt is actually parallel to tr, because one is a scalar multiple of the other. So the 3 in this case, this is what we are calling the scalar multiple. Now the common point you can see is t. So to show that these particular points are collinear, you simply need to show us that one of the points, that is the vectors formed from the 3 points, are scalar multiples of each other, and that there is a point which is being repeated. Therefore we'll simply say that, so this is the final statement that you state. So we'll say that since pt, since the vector pt is equals to 3tr, is equals to 3tr, it shows that that is, it follows that pt, vector pt is parallel to vector tr, and t, the point t, and t is common, or shared. T is common, or you can say t is being shared, is the shared point. Hence t, that is it was ptr, so we'll say hence p comma t and r, hence pt and r are simply collinear. Hence pt and r are collinear, they are collinear. So the marking points are when you show us that one of the vectors is a scalar multiple of the other, then the other marking point is telling us that there is a point which is being shared. So in this case, point t. So the marking point will be here, then the other marking point will be telling us the point that is being shared. So next time we'll be looking at further examples, of course, on the same topic. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.